NASA study suggests that non-living processes do not explain all the organic matter found on Mars.
New research led by NASA scientists shows that purely non-biological explanations cannot explain the amount of organic compounds detected in a sample collected by the Curiosity rover on Mars.
It all started in March 2025, when the team announced the identification of relatively large molecules, decane, undecane, and dodecane, inside a rock analyzed by the robot's chemical laboratory. These substances, the largest organic molecules ever found on the red planet so far, were preserved in an ancient mud deposit in Gale Crater. The researchers hypothesized that they could be fragments of fatty acids, a type of compound that, here on Earth, is mainly produced by living beings, although it can also arise through geological processes in specific conditions. Since Curiosity's instruments don't allow us to say for sure whether these molecules came from life or not, scientists decided to investigate further. They evaluated the main known non-biological sources, such as the arrival of organic matter through meteorites that collide with the Martian surface. To do this, they combined laboratory experiments simulating cosmic radiation, mathematical modeling, and real data collected by the rover. The result was surprising. By turning back the clock about 80 million years, a period in which the rock was exposed to intense radiation from space, which gradually destroys organic molecules, the researchers estimated that the original amount of organic material present was much greater than what known non-biological processes could realistically produce, even adding several possible sources, such as meteorite impacts and chemical reactions on the surface. It does not come close to the calculated abundance.
Given this, the study, published in early February 2026 in the journal Astrobiology, concludes that it is reasonable to consider the hypothesis that life forms, possibly microorganisms that existed in Mars' distant past, may have contributed to the formation of these compounds. The authors are keen to highlight that this is not proof of life on the red planet. There are still many pieces missing to put together the puzzle. More research is needed, especially to better understand the speed at which organic molecules degrade under Mars-like conditions. Only in this way will it be possible to reach firmer conclusions about the presence or absence of life in the planet's past. For now, the discovery reinforces the mystery and fascination surrounding Martian organic matter, showing that the chemical history of Mars may be more complex and interesting than we imagined.